Hi guys, today we'll be looking at section 3F negative indices. Let's take a look at the learning intentions first. Our first learning intentions is to understand how a negative power relates to division. Second, to know how to rewrite expressions involving negative indices with positive indices. And lastly, to be able to apply index laws to expressions involving negative indices. The study of indices can be extended to include negative powers. Using the second index law at the zero power, we can establish the rules for negative powers. For example, the first one, a to the power of negative n is equal to 1 over a to the power of n. A negative index indicates an inverse or reciprocal. All right, I can show you. Remember, a to the power of 0 is equal to 1. So if we make this a to the power of 0 over a to the power of n by applying index law, that's a to the power of 0 minus n, okay? So that's a to the power of negative n, all right? And this, don't forget that a to the power of 0 is just equal to 1, okay? So 1 over a to the power of n is equal to a to the power of negative n. Next one, again, we can apply that. 1 over a to the power of negative m is equal to a to the power of 0 over a to the power of negative m. So that's a to the power of 0 minus m minus m. So a to the power of m. Okay, so it's just it's not big, it's not a new thing. It's just um, applying index law. All right, next one. Express each of the following using positive indices. Okay, so b to the power of negative 3 is 1 over b to the power of 3. Okay, so it's reciprocal. Next one, 2 and y to the 3, y to the power of 3, they are both positive. Just here is x to the power of negative 2. So let's make it as 2x to the power of 1 of x squared y to the power of 3. So write as a single fraction, 2y cubed over x squared. Okay. So this question wants us to using positive indices. So we don't want those negative numbers happens. All right, here we've got negative 4. We don't want this happen. We want to turn it to a positive number. And remember, x to the power of m, negative m, is x 1 over x to the power of m. Okay. So this one is actually 2 over 1 over x to the power of 4. So 2 divided by a fraction, you can turn it to multiply by its reciprocal, x to the power of 4 over 1. So your answer is 2 times x to the power of 4. Okay. Next one. Alternatively, actually, I've just found an easier method. Okay. We know 1 over a to the power of negative m is equal to a to the power of m. So this is like 2 times 1 over x to the power of negative 4. So it's 2 times x to the power of 4. So your answer is 2x to the power of 4. I think this might be easier. Next one. All of them are positive, but they are not simplified. Okay, so we need to simplify them. So 5 stays here. And a to the power of 2 on the top, a to the power of 4. So this could be canceled out. On the top is gone, but on the bottom is left with 2. That's a to the power of 4, a to the power of 2. P cubed and b to the power of 7 to simplify that. So left us with b to the power of 4. Okay, so that's your final answer. Okay, when simplifying more complex problems, always convert negative indices to positive before canceling. Yeah, because it's a lot easier to cancel the bases with positive indices. So that's why we do that. But you don't have to do that. You can always apply index law. Just be careful with the signs. For example, here, 3 over 9 could be cancelled, could be simplified as 3 and 9. This becomes 3 on the bottom. And all right, here, let's turn this to positive. M to the power negative 3 is 1. You can make it as m to the power 4 plus 3. Okay, because this one, m to the power negative 3, could be moved down to the bottom. N to the power 6, n to the power 6. And look at that, n to the power negative 2, you can move upwards. So it becomes plus 2. Okay. Actually, I think it might be easier just simply apply index laws. All right. 3 over 9, that's 1/3. 3 on the bottom. And then m to the power negative 3. So m negative 3 and m to the power 4. So divide by m to the power 4, that's minus 4. Okay, because a to the power m over a to the power n is a to the power m minus n. Okay. A to the power m minus n. So let's take a look at n. N to the power 6 over n to the power negative 2. That's minus 2. So that's m to the power negative 7, n to the power 8 over 3. Okay, but we have negative indexes here. So you can move this down to the bottom. That's n to the power 8 over 3 m to the power 7. So final answer is n to the power 8 over 3 m to the power 7. All right. Next one, more complicated one. So when we see brackets, we do brackets first. There we go. P to the power of negative 3. So you're going to distribute across bases. Q cubed over 2p to the power of negative 2, q squared, times p to the power of 2 over q to the power of negative 2. Okay, so distribute indices across bases. And then let's work it out. So we could combine them first. P to the power of negative 3, q to the power of 3, times p squared over 2p to the power of negative 2, negative 2, q squared, times q to the power of negative 2. All right, here we have p to the power of negative 3 plus 2. All right, and the q to the power of 3 over 2p to the power of negative 2, and the q to the power of 2 minus 2. Okay, there are a lot of letters in it, just be careful. So q to the power of 2 minus 2. So your final answer, not final answer, your next step, p to the power of negative 1, q to the power of 3, 2 p squared, q to the power of 4. Okay, and then you can simplify. So 1/2 p to the negative 1 on the top, negative 1 minus 2. Okay, and the q, 3 minus 4. So p to the negative 3 and q to the power of negative 1 over 2. These are negative indices. We don't like it. Let's make it that positive so they can be flipped. So 1 over p to the power of 2, p to the power of 3, q. Okay, because q to the power of 1 is just q. All right, last example I'm going to talk about. Again, gonna distribute the powers of power spaces. So 2 square m to the power 4 over r to the power of 8 n to the power of -6 divided by 12, no, not 12, my bad, 4 to the power of 3 m to the power of -3 n to the power of 6 over r cubed. Okay, and then we can simplify. Now, before simplifying, let's turn this, okay? Divide by a fraction, we multiply its reciprocal. 2 squared, which is 4, 4m to the power of 4 over r to the power of 8, n to the power of -6, times, so you flip it, r to the power of 3, 4 cubed, which is 64, m to the power of -3, n to the power of 6. All right, and now let's simplify. So r cubed here, and r to the power of 8. So let's cancel out. We have r to the power of 8 here. This is just r to the power of 3. So it could be simplified as r to the power of 5. Okay. And what else can we have? 4. Add this one gives us 16. All right. Okay, let's write it down. M to the power of 4, r to the power of 5, n to the power of -6 times 16, m to the power of -3 times n to the power of 6. Okay. So we have m to the power of 4 over, okay, here, n to the power of -6 and n to the power of 6, this could be combined as n to the power of 0, okay? So r to the power of 5, n to the power of 0 times 16. Here, m to the power of -3 could be flipped, so times m to the power of 3. So your final answer, m to the power of 7 over 16, r to the power of 5. Okay, because with this kind of question, be careful, okay? Do step by step. All right, that's the end of my part. And now it's your time to complete the question for exercise 3F in your workbook. And also be mindful, those are some useful videos for you to have a look, okay? All right, see ya.